Lesson 8-5, Problem Solving Strategy, Drawing a Graph. In this lesson, you learn to solve problems by using graphs. It is important because using graphs allow you to see patterns in data. So imagine you are sitting in your summer clothes and sandals eating lunch and it's 74 degrees below zero. It's happening every day on high-flying airplanes that are far from the heat of the Earth's surface. Okay? So the temperature at different altitudes above sea level, when temperature at sea level is 60 degrees Fahrenheit, is shown in the table at the left. So you have altitude in thousands of feet, 5,000 feet, temperature is 41 degrees. Altitude in 10,000 feet is around 23 degrees, and so on and so forth, all the way to 25,000 feet, which is negative 33 degrees Celsius. So the table does not include an altitude for negative 74 degrees Celsius. At what altitude would a jet be flying when the thermometer has this reading? And we will solve this problem in example number 1. So a graph represents the same information as its equation, but because a graph is visual, it allows you to see patterns that may not be obvious from an equation. A graph is a powerful tool in problem solving. Let's refer to the application at the beginning of the lesson. Find the altitude where the thermometer is negative 74 degrees Fahrenheit. And let's assume that the temperature decreases at a constant rate. So what do we know? You need to estimate an altitude that is not in the table. You know that the temperature at 5 different altitudes and the temperature decreases at a constant rate. So how do we plan to solve this? One way to solve this problem is to graph the given information, then read the graph to find an altitude that corresponds to a temperature of negative 74 degrees. So we make a graph. Let the horizontal axis of the graph represent the altitude. Let the vertical axis represent the temperature. Okay, and graph each ordered pair on this table. So we'll graph that each ordered pair on that table using the pairs of values taken from the table. Then draw the line that contains these points, and that is your graph. Okay, after we graph these points and we connect them with a straight line, that's what you get. Okay, then we have at this point an estimate of negative 74 degrees would be right around, okay, let's make that into a straight line. Let's make that red thin line. Okay, so an estimate of negative 74 would be halfway between negative 70 and negative 80. So that's here, right here. So negative 74. Why is it so black? That works. Okay. So negative 74 will be around halfway between negative 70 and negative 80 on the vertical axis. Okay. Estimate the altitude by reading the corresponding value on the horizontal axis. After finding negative 74, we simply read the corresponding altitude on the horizontal axis. So the ordered pair is around 36 and negative 74, very close to where I put the line, appears to be on the graph. So negative 74 corresponds to 36,000 feet, which means that at 36,000 feet, that our temperature would be negative 74 degrees Celsius. Oh, sorry, Fahrenheit. Okay, how do we check this? Is the solution reasonable? The lowest temperature in the table is negative 33. It corresponds to an altitude of 25,000 feet. The temperature drops around 19 degrees for each 5,000 feet. Okay, so because it says it drops at a constant rate. So the increase in altitude, negative 74 minus negative 33, is equal to 41, because that becomes negative 74 plus 33. That becomes negative 41. And negative 41 is about 2 times negative 19. Okay, therefore the altitude will be about 2 times 5,000 or 10,000 feet higher. And since our last value is 25,000 feet, we simply add that 10,000. It's reasonable. 35,000, a solution to 36,000 is reasonable. Actually, if you look at the line that I made, it is actually closer to 35,000 than 36,000. Okay? And that's how you use a graph to be able to predict, okay, a particular information that you don't have, okay, on your table. Okay, and you can also use a graphing calculator to plot points and construct a line, but we're not going to use that without erasing the points. And you can use the trace function to answer the question. So we're not going to use a calculator. We're going to use GeoGebra. Okay, the ordered pairs 50.7, 16.47, and 99.2 and 25.42 are represent data from two rows of a table comparing cubic meters of natural gas used and the cost. So this is the natural gas used, and that's the cost. Okay, so the natural gas used is 50.7, the cost is 16.47. Okay, the natural gas used is 19.2, the cost is 25.42. Okay, so it's asking what would the bill be for 140 cubic meters of natural gas be. So this is our, if you notice, this is our x coordinate and this is our y coordinate. So we will use a scatter plot procedure on page 379 to plot the two ordered pairs. In this case, we're not using a graphing calculator. I'm using GeoGebra, and I plotted the 2 points. Okay, 50.7, 16.47. Okay, and this is point K, and this is point L. Okay, just for reference. So that's point K and that's point L. Okay, and the next thing we need to do is we need to connect those 2 points with a line. Okay, now we have a straight line, and now we can estimate 140 cubic meters, which is around here, right there, of natural gas. And if we look at the vertical axis, where that would be, it would be right there. Okay, and that value would be, okay, the x-coordinate is about 140. The corresponding value of y is the cost of 140 cubic meters of gas, and that would be around $32.80. So for the gas, for 140 cubic meters of natural gas used, the cost is around $32.80, and this is around $32.80, right around there. Okay, that's around $32.80. I don't know where they found 80 cents from, but that's close enough. Okay, and the secret word for this particular lesson is Carolina. Secret word is Carolina. Okay, and that's the end of our lesson. Thanks for watching.